Hello students, welcome to Learn with JJ Academy. In today's video, we are going to see the concept Fourier series, one of the very important topic of engineering mathematics. Most of the students are very scared about this topic because of maybe it has lots of steps and big formulas, but don't worry, it's very simple. I'm going to explain you in simple way, okay, so that your topic will be clear. So without wasting time, let's start today's video. So this is our main Fourier series. F of x is equal to a0 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. You have to remember this series, okay? While solving every question of Fourier series, initially first step should be you have to write down this Fourier series. You have to write down this Fourier series, okay? You can see here in this series there are three terms. First one is a0, second one is an, and third one is bn. Okay, so what you have to do first while solving question, initially you have to write down this equation. Okay, you have to consider this equation as equation number 1, and then you have to find the value of a0, an and bn first. Okay, so let's see, we have formula of a0, an and bn also. So the formula of a0 is 1 over 2 pi integration of limit 0 to 2 pi. 0 to 2 pi are given limits. Okay, in question they will mention you the given limits 0 to 2 pi, or one more limit is there, one more interval is there, minus pi to pi. Okay, remember, so either they will give you 0 to 2 pi or minus pi to pi. So if they have given 0 to 2 pi, your formula will be a0 is equal to 1 over 2 pi integration of limit 0 to 2 pi f of x dx. Okay, f of x means given function, either it will be x square, sin x, e raised to x, whatever. Okay, or if they have given limit minus pi to pi, then your formula will become a0 is equal to 1 upon 2 pi will be as it is outside. Okay, you have to just change the given limits, means here instead of 0 to 2 pi what you have to put minus pi to pi, and remaining term will be as it is f of x dx. Okay, so what you have to do, you have to just change the limits, whatever the given limits they have given, you have to just replace that limits. Okay, so this is the formula of a0. Similarly an, the formula of an is 1 over pi, given limit 0 to 2 pi, so put here 0 to 2 pi, f of x into cos nx. Always remember in an we use cos term. Okay, so to find value of an you have to use f of x into cos nx, means here you have to use u into v formula. In next slide we'll see u into v formula also, but remember this, to find the value of an and bn you have to compulsory use u into v formula. So to find an you have to use f of x into cos nx. Okay, and if the limits they have given minus pi to pi, then you have to just replace the limits here minus pi to pi. That's it. Okay, remaining formula will be same. Similarly bn, the formula of bn is again same, 1 over pi. You can see here in an and bn outside term is 1 over pi, and in a0 outside term is 1 over 2 pi. Remember this. Okay, so bn is equal to 1 over pi, limits again given limits you have to put here 0 to 2 pi or minus pi to pi, whatever the given limits are there you have to put the limits here, f of x into sin nx. Remember, to find the value of bn you have to use sin term, to find the value of an you have to use cos term. Okay, and the formulas are almost same, f of x into sin nx dx. Here also you have to use u into v formula. So what you have to do first, initially you have to write down the given main our Fourier series, then you have to find value of a0, an and bn. Okay, and after finding these three values, what you have to do, you have to put all these values in main series. Okay, so the whatever series you will get, that will be a required Fourier series. Okay, we'll see an example so that your topic will be clear. So these formulas, this is our main Fourier series, you have to remember, you have to by heart it, no option, and a0, an and bn, these three formulas also you have to remember. Okay, product rule, to find the value of an and bn, okay, to find the value of an and bn you have to use product rule. Okay, so what exactly this product rule, we have one product rule for polytechnic. Okay, but in engineering you have to use this formula as a product rule, means here you can see here u is first term and v is second term, and you know how to find first term and second term by using that Lie pattern. I'm not going to explain that Lie pattern, but you should know this. Okay, which one is first term and which one is second term, you should understand first. Then now here u is first term and v is second term, so the direct formula is u as it is, means first term as it is, into v1. v1 means integration of v. Okay, so u as it is into integration of v minus, you can see here first term is plus, so second term you have to consider minus sign, minus derivative of first term. So derivative of u is denoted by dash, remember. So derivative of u is u dash, and you have to find integration of v1, that is v2. Okay, then second term is minus, third term is again plus. Okay, you have to give alternate sign, means first term should be plus, second minus, third term again plus. Again derivative of u dash will be u double dash, and integration of v2 will be v3. Okay, third term is positive, so fourth term will be negative. So again derivative of u double dash will be u triple dash, and integration of v3 will be v4. In this way you can apply the u into v formula till you are getting derivative as a zero term. Okay, for example, I will show you one example here. Is for example, suppose we have x square into e raised to 3x. Okay, so you can see here x square is first term, e raised to 3x is second term, because x square is algebraic and e raised to x is exponential. So in Layet pattern, x square come first and then e raised to 3x. Okay, so the formula is first term as it is, that means x square as it is, into integration of second term, e raised to 3x integration will be e raised to 3x over 3. Okay, you have to divide coefficient, remember this. First term is positive, then second term is negative, minus derivative of x square. The derivative of x square is 2x. Okay, and then integration of second term means again you have to find integration of e raised to 3x, that is e raised to 3x over 3, but already we have 3, so 3 times 3 will be 9. Okay, after second term you have to find third term. Second term is already negative, so you have to consider third term as positive. Derivative of 2x will be 2. Okay, derivative of 2x will be 2. You no need to consider that negative sign. Okay, that negative sign is of for formula. Okay, you have to consider only 2x, so derivative of 2x will be 2 into again integration of second term. So integration of e raised to 3x will be e raised to 3x over 3, but already 9 we have, so 3 into 9 will be 27, minus again you have to find derivative of 2, so derivative of 2 will be what, 0. So this will be your last step. Okay, so in this way you can apply u into v rule. Okay, any two terms they will give you, you have to just put both the terms in formulas. Okay, so this was the product rule, you have to remember anyhow to solve Fourier series questions. Now these are some important terms you should know. You should by heart this values, like sine 0, the value of sine 0 is 0. Similarly sine n pi, sine pi series is 0, remember. Sine pi, 2 pi, 3 pi up to n pi, all values are always 0. Then obviously sine 2n pi will also be same 0. Okay, cos 0, the value of cos 0 is 1. Okay, cos n pi, this is the standard value, cos n pi is equal to minus 1 raised to n. Remember this, mostly we use this value, this term in while solving the questions. Okay, so cos n pi is equal to minus 1 raised to n. And finally cos 2n pi, cos 2n pi is equal to also 1. Or simply remember this, cos 0, 2 pi, 4 pi, means in cos if angle is even the value is positive 1, and cos pi, 3 pi, 5 pi, if the angle is odd then its value will be negative 1. Okay, remember this. And in sine 0, pi, 2 pi, 3 pi, 4 pi, means whether the angle is odd or even, its value will also its value is always 0. Remember this. Okay, because sine pi series is 0. So these are some important values or formulas you should remember to solve while solving the question of Fourier series. Okay, let's move to the question now. So question will be asked like this. Okay, mostly the question is asked for 6 marks. Find the Fourier series of f of x is equal to x square in interval 0 to 2 pi. They have given interval also here, 0 to 2 pi. Okay, so what your first step will be? Your first step should be, you have to write down our main Fourier series. So we know that f of x is equal to a0 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn into sin nx. Consider this equation as equation number 1. Okay, now initially find value of a0. So we have the formula. So the formula is a0 is equal to 1 upon 2 pi integration of limits. You have to put given limits. So here limits are 0 to 2 pi. So you have to put here 0 to 2 pi. Instead of 0 to 2 pi, if they would have given minus pi to pi, then we would have put here minus pi to pi limits. Okay, f of x here, x square. So put here f of x square. Okay, f of x they have given x square, so I have put here x square. So is equal to 1 over 2 pi. What is the integration of x square? So what you have to do, you have to just add 1 in power. So 2 plus 1 will be 3. So x to the power 3 over 3 square bracket complete, and on right hand side you have to put limits 0 to 2 pi. So 1 by 3 is constant here. I am taking outside from the bracket. So outside already we have 2 pi. So it will become 6 pi. Inside you will get only x cube, and limits we have 0 to 2 pi. Okay. So now 1 over 6 pi. We know that 2 pi is upper limit, 0 is a lower limit. So instead of x, initially you have to put upper limit. So you will get 2 pi cube, and minus lower limit is here 0. So is equal to 1 over 6 pi, 2 cube is 8, and pi cube. Okay. So now a0 is equal to, what you have to do, you have to just simplify this. So you can see here pi get cancelled. So the answer is 4 pi square pi 3. This will be the value of your a0. This will be the value of a0. Find this value, you will get 1 mark. Okay, write down main Fourier series, you will also get 1 mark. So till this step you will get 2 marks. Okay, next what you have to do, you have to find an. You have to find the value of an. So for an, we know the formula of an. The formula of an is, where we use f of x into cos nx. While considering an, we use cos nx term. So I'm writing here formula 1 upon pi, limits are same 0 to 2 pi, f of x into cos nx dx. Okay, so is equal to 1 over pi 0 to 2 pi, f of x here we have x square, and into cos nx dx. Okay. So in layered pattern, LIA, algebraic term first, means x square is here first term, cos nx is here second term. Okay, so you have to use unit to formula here. So the formula is first term as it is, means x square as it is, into integration of second term, integration of cos is sine nx divided by n. Coefficient of x is here n, so put n, minus derivative of first term, derivative of x square is 2x, into again integration of sine is minus cos. So minus cos nx divided by n. Already n we have, so n into n will become n square, plus second term is negative, third term is again positive, plus again derivative of 2x will be 2 into integration of minus cos will be minus sine. So minus sine nx over n. Already n square we have, so it will become n cube. And after 2, the derivative of 2 will be 0. So this will be your last step, and you have to put limits on right hand side like this. Okay, so already we have seen some important results. In that important results, we know that sine pi series is 0. Sine pi series is 0. So you can see here first term and third term. In first term and third term, sine term is there. It means first term and third term will become 0, because limits are 2 pi and 0. So sine 2 pi is also 0, and sine 0 is also 0. Okay, so what you have to do, I'm directly showing here 0, but in exam you have to show the steps. Okay, so you have to put limits, and then in next step you have to show the value is 0. Okay, so sine term is here, so sine 2 pi is 0, so put here 0, minus this minus minus will become plus 2 into 2 pi into cos 2n pi divided by n square, and plus third term is again 0. Okay, minus lower limit is here 0, so you can see here sine 0 0, even first term and third term is 0, but in second term also 2 into 0 will also be same 0. Okay, so the value of an is equal to 1 over pi into 2 into 2 pi will be 4 pi, and cos 2n pi we have value of cos 2n pi is 1, so 1 upon n square. Okay, so you can see here 4 pi get cancelled, so the value of an will be 4 upon n square. Find the value of an, you will get 1 more mark. Okay, so till this step you will get total 3 marks. Okay, and finally you have to find the value of bn. So again same, the bn is equal to, we have formula 1 upon pi, limits are again same, integration of limit 0 to 2 pi f of x into sine nx dx. Okay, so is equal to 1 upon pi integration of limit 0 to 2 pi x square, f of x is here x square into sine nx dx. Okay, so now what I am doing, 1 upon pi, you have to use u into v formula here. So the formula is first term as it is, that is x square as it is, into integration of sine minus cos. So minus cos nx upon n minus derivative of x square is 2x into, again minus cos integration will be minus sine nx upon n square, and plus again derivative of 2x will be 2, and integration of sine is minus cos, so minus sine integration will be plus cos. So cos nx divided by n cube. Okay, bracket complete, you have to use limits 0 to 2 pi. So here 1 over pi, now you can see second term only have sine term, right? So the second term will become 0 and first term and third term will be as it is. So what I am doing, minus x square, instead of x initially put 2 pi, so you will get cos 2n pi, cos 2n pi divided by n, minus second term is 0, plus 2 into cos 2n pi divided by n cube, and minus, now you have to put lower limit, so first term 0 into cos n pi will be 0, even second term is sine, so again it will be 0, and minus 2 cos 0 upon n cube. Okay, means while putting the lower limit 0, your first term and second term will become 0, only in third term you have to put x equal to 0. Now you can see here third term is positive here, but while putting lower limit we take minus sign in between them, so that's why this third term will become minus. Okay, so now 1 over pi in bracket, sorry, here I have to put 2 pi, so this 2 pi square will become minus 4 pi square, cos 2n pi is 1 over n, and plus 2 into, again cos 2n pi is 1 over n cube, and minus 2 into, again cos term is 1 over n cube. So you can see here this term and this term is same, so get cancel. Okay, so the value of bn is equal to 1 over pi in bracket minus 4 pi square over n, right? So bn is equal to, if I cancel pi, so we'll get minus 4 by n, minus 4 by n. Solve till this step, you will get 4 marks. Okay, 1 more mark. And finally what you have to do, you have to just put the value of a0, an and bn in equation number 1 in main series, so you will get the required Fourier series. So this will be your final answer. In this way you can solve any questions on Fourier series. I hope this question is clear to you. Okay, let's solve one more question in another interval, in different interval. Okay, so your topic will be clear. Now you can see here, find the Fourier series of f of x is equal to e raised to ax in minus pi to pi. So what we will do first here, initially you have to write main Fourier series. Okay, so we know our main Fourier series, that is f of x is equal to a0 plus summation n is equal to 1 to infinity an cos nx, and plus summation n is equal to 1 to infinity bn sin nx. Consider equation number 1. initially solve a0, so the formula of a0 is 1 over 2 pi. Now you can see here they have given limits minus pi to pi, so you have to put minus pi to pi here. Okay, f of x dx, so 1 over 2 pi minus pi to pi, f of x here is e raised to ax, e raised to ax dx. So we know the formula of integration of e raised to x. What is the formula of integration of e raised to x dx? That is e raised to ax over a. This we just divide the coefficient of x here. Okay, so you can see here I can directly write here 1 over 2 pi e raised to ax over a. Okay, and limits we have minus pi to pi, minus pi to pi. Okay, so a is constant, so I'm taking outside, so I can write 1 upon 2 pi a, and inside only you will get e raised to ax, limits we have minus pi to pi. Okay, next 1 upon 2 pi a, instead of x initially put upper limit, so you will get e raised to a pi, minus, instead of x now put lower limit, so you will get e raised to minus a pi, right? Next what you will do, what I'm doing, 1 upon a pi, I'm just taking this 2, outside 2 I'm taking inside, so you will get e raised to a pi minus e raised to minus a pi divided by 2. Okay, so we have one formula, it is called as conversion of trigonometry into hyperbolic. So sin hx is equal to e raised to ax minus e raised to minus ax divided by 2. Okay, so you can see here instead of x here we have pi, so I can directly write a0 is equal to 1 upon a pi into this formula is sin h a pi formula. Okay, e raised to a pi minus e raised to minus a pi over 2, I can write directly sin h a pi. Okay, I've just used this formula. Okay, remember this, if positive sign is there, so that time you use cos formula, cos h a pi. Okay, so this is the value of a0 first. Now you have to find the value of an. So we have the formula of an is equal to 1 over pi minus pi to pi f of x into cos nx dx, right? So 1 over pi, limits minus pi to pi, f of x here we have e raised to ax into cos nx dx. Okay, so here we can't use the u into u formula because you won't get derivative of e raised to term cos term as a 0, because derivative of cos is sine, derivative of sine is again minus cos, derivative of cos is minus sine, derivative of sine again cos, so it won't become 0. So for that we have one standard formula, means e raised to ax, e raised to ax into cos bx dx is equal to, the formula is e raised to ax upon a square plus b square in bracket a cos bx plus b sin bx. Okay, this is the standard formula for u into v of e raised to x into cos bx. Okay, so what I'm doing now, 1 over pi, I'm applying directly this formula. So e raised to x, both the terms are same, but here in formula we have cos bx and here we have cos nx. So what you have to put, you have to put a is equal to a, same term, but you have to put b is equal to n in this formula. Okay, so you will get e raised to ax upon a square plus n square. Okay, instead of b I am putting n here in bracket a cos bx, that is a cos nx, and plus b sin bx, that is n into sin nx, bracket complete, and limits we have minus pi to pi. Okay, so 1 upon pi, a square plus n square constant, so I'm taking outside. Okay, in bracket we will get e raised to ax into a cos nx plus b sin nx. Okay, and limits again same, minus pi to pi. Now an is equal to 1 upon pi into a square plus n square in bracket. You can see here, instead of x initially I have to put upper limit pi. Okay, so sin n pi we know the 0, so its value will be e raised to a pi into a cos n pi. That's it. Okay, minus, now in same equation you have to put minus lower limit, so e raised to minus a pi into a into again cos n pi. Okay, because sine term is 0 here, sine term is 0, so is equal to 1 upon pi into a square plus n square in bracket e raised to a pi into a into, we know the value of cos n pi. The value of cos n pi is minus 1 raised to n, so you have to put here minus 1 raised to n minus e raised to minus a pi into again a into minus 1 raised to n. Okay, minus 1 raised to n. So what I'm doing now, I'm taking a into minus 1 raised to n outside divided by a square plus n square. Okay, so in bracket you will get e raised to a pi minus e raised to minus a pi. Okay, and this pi also here outside, so I'm taking inside. So but we need 2 pi to apply the formula, so what I'm doing, I'm just multiplying 2 and dividing by 2 here. So the value of an will become 2a into minus 1 raised to n divided by a square plus n square into, already we have applied this formula in a0, so its formula will be sin ha pi, sin ha pi. This will be the value of an, this will be the value of an. Similarly you can find the value of bn. Bn is equal to again same 1 over pi minus pi to pi f of x here e raised to ax into sin nx, right, sin nx dx. So the formula of integration of e raised to ax into sin bx dx is equal to e raised to ax over a square plus b square in bracket a sin bx minus b into cos bx. Okay, so again same, you have to put a is equal to a and b is equal to 9 here in this formula, so you will get 1 upon pi in bracket e raised to ax upon a square plus, you have to just replace b by n. Okay, in bracket a sin bx, that is a into sin nx, and minus b means n into cos nx. Okay, so again same, 1 upon pi a square plus n square you can take outside. Okay, so in bracket you will get e raised to ax into a sin nx minus n cos nx, minus n cos nx. Okay, minus n cos nx. So now what you have to do, you have to just integrate this term. So to integrate, again sine term is here, so the derivative of sine we know, the value of sine we know, that's 0. So what I am doing is equal to 1 upon pi a square plus n square in bracket, initially I am putting upper limit, so limits we have minus pi to pi here, so e raised to a pi into, you can see our first term is sine here, right, so sine term is 0, so 0 means minus n into cos n pi you will get. Okay, but in exam you have to show, you have to put the value of pi first, both side. Okay, in next step you have to show the value of sine is 0, minus e raised to minus a pi, again same here, sine 0 is 0, so you will get minus n into cos minus theta is cos theta, so cos minus n pi will also again same cos n pi only, remember this. Okay, so now 1 upon pi into a square plus n square, what I'm doing, I'm taking n cos n pi. Okay, before that, minus e raised to a pi into n, the value of cos n pi we know, minus 1 raised to n, put here again same, this minus and this minus will become plus, so e raised to minus a pi into n into again minus 1 raised to n. Okay, so now what I'm doing, I'm just doing adjustment, like I'm taking minus common and minus n minus 1 raised to n I'm taking outside, and pi a square plus n square, so in bracket you will get this minus e raised to a pi will become plus e raised to a pi. Okay, and minus e raised to minus a pi. Okay, n into minus 1 raised to already we have taken outside, so now do adjustment, multiply and divide by 2, so minus 2 n into minus 1 raised to n divided by a square plus n square, and here you will get e raised to a pi minus e raised to minus a pi divided by 2. Okay, I just multiply and divide by 2 here, so the value of bn will be minus 2n into minus 1 raised to n divided by a square plus n square, and we know the value of this, that is sine h a pi, sine h a pi. Okay, so this will be the value of bn. Okay, and we know that after the finding value of a0, an and bn, what we do, we put all three values in main equation number 1. So whatever series you will get, that will be your required Fourier series. Okay, so in this way you can solve any questions of Fourier series. Okay, but for that you should know the product rule formula, the values of sine 0, cos 0, sine n pi, cos n pi, then only you can solve this kind of questions. Okay, in next videos we are going to solve more questions on the Fourier series. Okay, so that your all concepts of Fourier series or all your fear will come outside. Okay, so to get notification of our next videos, just like, subscribe and share our channel. Okay, see you in next lecture. Till then, take care. Bye bye.